In today's lesson, we're going to be looking at graphing rational functions with oblique, also known as slant asymptotes. So in a previous lesson, I had graphed rational functions where the degree of the top and bottom were equal. I'll link that in the top right-hand corner if you need to see that lesson, but our focus today on this lesson is graphing oblique, also known as slant asymptotes. Oblique or slant asymptotes exist when the degree of the numerator is exactly one more than the degree of the denominator. So you'll see in this example here, the degree of the numerator here, this polynomial on the top is 2, degree of the bottom is 1. This will create a slant or oblique asymptote. Let's take a look at graphing some rational functions which have these slant or oblique asymptotes. So in our first example here, we have a rational function. I want to go ahead and find the slant asymptote. So what we do first is we go to long division. What I'm going to do is I'm going to go through long division. I'm going to take my divisor of x minus 5. I'm going to divide that into our polynomial we have in the numerator here. Going through long division, we get the following. So going ahead and doing long division, I end up getting that my quotient here is 2x plus 3, and then my remainder is an 8 here. So now how do we use this to find our slant asymptote? Well, what we know is if I use the division algorithm, we get the following decomposition. By the division algorithm here, we have our polynomial breaks up to my quotient times my divisor plus my remainder. Now I'm going to go ahead and do is I want to recreate my rational function r at x here. So I'm going to divide across by x minus 5. Right across the equal sign here on every single term. We get cancellation here, and now you can see here, this right here is my rational function r at x that we've been working with. Ends up decomposing into 2x plus 3 plus 8 over x minus 5. So now when we examine slant asymptotes, it's much like examining horizontal asymptotes. We want to look at the outer bounds of the function. So as x gets infinitely small or infinitely large, where does our rational function tend towards? Well, as x approaches positive or negative infinity, we can see here that the 8 over x minus 5 must approach 0. Right? As x gets infinitely large, the bottom is going to go to bigger and bigger numbers, in which case 8 divided by that will tend towards 0. So therefore, as x gets infinitely large or infinitely small, my rational function, since this section of the rational function is approaching 0, my rational function will now approach 2x plus 3. So that means that this rational function has a slant asymptote at 2x plus 3. And what that means is as x gets infinitely large or infinitely small, my rational function will approach and sort of mimic the motion of the linear equation 2x plus 3. It'll never be the linear equation 2x plus 3. It'll get infinitely close to it, either above or below that line. It will never become that line and like take over that line, but it'll approach it infinitely from either below or above. Let's take a look at finding some other characteristics of this rational function and graph everything together. So now we know our rational function has a slant asymptote of y equals 2x plus 3. The next observation here is you cannot have a horizontal asymptote. If I have a slant asymptote, I cannot have a horizontal asymptote. You can't have a rational function that has both of these things. The reason for that is your slant asymptote exists when x is infinitely large or infinitely small. So the same is said to be for your horizontal asymptote. So you can't have a rational function that as it gets infinitely large or infinitely small, it approaches 2x plus 3 and also approaches some horizontal asymptote, let's say y equals a half, whatever that may be. So you can't have a slant asymptote and a horizontal asymptote for these rational functions. Moving on though, we do have a vertical asymptote, in which case the vertical asymptote is going to be x equals 5. And again, as a reminder, that exists when the bottom is 0. We have y-intercept. Y-intercept happens when you evaluate your function, in this case r at 0, in which case we're going to get 7/5. And we have an x-intercept here. To examine the x-intercept, take a look at the top. And I'm going to look at the discriminant of this. Quadratic is going to be negative 7 squared minus 4ac. And calculating this here, I end up getting 49 plus 56. I end up getting 105. Using the quadratic equation, I have that the x-intercepts are going to be 7 plus or minus the root of 105 over 2 times 2, which is 7 plus or minus the root of 105 over 4. So now I have my two rational equations. This will be 7 plus or minus the root of 105 over 4. Now, if we're going to go ahead and graph this here, you're not going to tell someone to plot an x-intercept at 7 plus the root of 105 divided by 4, or 7 minus the root of 105 divided by 4. You have to get this down to a decimal place, some approximate value. So plugging this in your calculator, you end up getting the two values are 4.31 and negative 0.81. And those are our approximate x-intercepts. Now let's put this all together and graph. So in graphing a rational function here, the first thing we want to graph is, let's graph our slant and vertical asymptotes. So I'm going to go ahead and do that now. Okay, I've went ahead and graphed my vertical asymptote and my slant asymptote. I now want to graph some other characteristics here. So I know that I have a y-intercept at 7/5. So again, you got to make sure that when you're plotting your x and y-intercepts that you hit these values at the proper side of the asymptote. So in this case here, my y-intercept is 7/5. I know that this y-intercept here is represented by a 3. So the idea here is my y-intercept is below my graph here. Let me adjust this just a little bit here. So now I have my y-intercept here. And now moving on here, I want to plot my x-intercept. So I have an x-intercept of 4.31. So that has to be to the left of 5. So we'll get an approximate point here. And then my next x-intercept is negative 0.81. Again, this value right here is where this line crosses the x-axis, which is going to be negative 3/2 or negative 1.5. So my other x-intercept of negative 0.81 is going to be somewhere around here. So I have a rough idea where everything is crossing at. So now I want to go ahead and graph my rational function. So when graphing your rational function, what you want to do is focus your attention on your vertical asymptote, because as I approach my vertical asymptote from the right-hand side, as I approach 5 from the right, either I'm tending towards negative infinity or tending towards positive infinity. If my graph was coming from below here, I would have to tend towards my slant asymptote, as you see, which would require me to cross my x-axis, which would require me to have an x-intercept in somewhere along this location here. I do not have that, so there's no way that the graph can be coming from below. The graph must be coming from above, in which case we get the following. Now we can do the same logic from the right-hand side. As I approach my vertical asymptote from the left-hand side, now it could be the case I'm coming from above, in which case I can cross here, bounce here, go like that. We could have something like this, but again, it is possible to cross your slant asymptote locally, just as it was possible to cross your horizontal asymptotes locally. That could be a situation, or we could be coming from below and it crosses, goes over, and then tends towards my slant asymptote. Since we don't know definitively what direction it's coming from, what I can do is, I know this is 4.31 and this is 5. I can pick a number between these two, let's say 4.5, and evaluate the function r at 4.5. If you evaluate this at 4.5, I can discover whether I am above or below the x-axis, and that'll tell me what direction I'm coming from. So evaluating this at 4.5, we end up getting here negative 4, so it's coming from below. So that means that the graph is going to tend up towards my first root, cross, hit my x-intercept and my y-intercept, and then tend towards my slant asymptote this way. And now we have a sketch of our rational function here. Let's take a look at another example. In the next example here, we want to graph the following rational function. One thing you want to do when you get a rational function is to try to factor everything fully, just to make sure that there's no cancellation, anything like that. So if I factor this fully here, this will factor into x minus 2, x plus 2, divided by x minus 1. So this factors nicely. And from here, there's a lot of characteristics that we can discover about our rational function quickly. We can see here that if I'm looking at x-intercepts, I can see I have x-intercept at plus or minus 2. If I were looking at y-intercepts, you're going to evaluate your function at 0, in which case we're going to get a y-intercept of 4. Continuing on here, vertical asymptotes exist when the bottom is 0, to which I get x equals 1. Now, I do not have a horizontal asymptote with this question, but we do have a slant asymptote. So let's go ahead and do long division and find our slant asymptote. And you end up getting here minus 3 for my remainder, and we have x plus 1 for my quotient. So using the division algorithm, we can do the same trick here. So I'm going to get x squared minus 4 factors into x minus 1 times x plus 1, and then minus 3. Once again, I can create my rational function just as we did before by dividing across by my denominator, in this case x minus 1. And again, we get our cancellation here. So this rational function decomposes into x plus 1 minus 3 over x minus 1. So now you can see here with this decomposition, as x gets infinitely large or infinitely small, once again, we have the property that, in this case, the negative 3 over x minus 1 will approach 0, leaving us again with our rational function approaching x plus 1. So as x gets infinitely large or infinitely small, our rational function will approach x plus 1, and this is our slant, also known as your oblique asymptote. In general, we do not have to do this entire step every time. You'll see here that in general, your slant asymptote will always be your quotient. Because if you notice in this example and the last example, this expression right here ends up being your remainder divided by your divisor. And since the process of long division always must be the case that the degree of your remainder is less than the degree of your divisor, it will always be the case that this rational function has the property that the degree of the top is strictly less than the degree of the bottom, and that'll always give you the property that your rational function will tend towards 0 as x gets infinitely large or infinitely small. So therefore, the only thing you'll ever be left with is your quotient, which will create your slant asymptote. Let's put this all together and graph our rational function. All right, going ahead and just kind of summarizing all our information here. First thing we do again is always graph your vertical and slant asymptotes. So I have a vertical asymptote at 1 and a slant at x plus 1. Let's go ahead and do that. So I went ahead and graphed my vertical and slant asymptotes. I now have an x-intercept at 2 and another one at minus 2. So again, be mindful here, this x-intercept is minus 1. So I've got an x-intercept happening on this side. I also have a y-intercept at 4. This y value here be somewhere up here. We know that this y-intercept is a 1. So we've got something along these lines. Okay, we want to go ahead and graph our rational function. Same idea. What we want to do here is we want to go ahead and as I approach 1, our vertical asymptote at 1, as I approach it from the right-hand side, if I were to be coming from above, I would then have to cross through my slant, which is fine, intersect with this, and then tend up towards this way. Or if I'm coming from below, I'd have to do something like this. So since both of these are a possibility, what I'm going to do instead is I have x of 1 and this is x of 2. I'm going to evaluate the function r at 1.5 and see whether I'm above or below the x-axis. So evaluating this at 1.5, we end up getting negative 3.5. So that means this is coming from below. So the graph is going to go here, cross through, and then tend towards my slant asymptote. Now moving along here, same idea. As I approach 1 from the left-hand side, I'm either coming from below or coming from above. Could be the case the graph comes from above, crosses through, and then tends towards, or possibly it comes this way. Now, if it came this way, I would have to cross my x-axis to get up to my y-intercept and then back down, which would mean I would need another x-intercept here, which I do not have. So again, it has to be the case that we're sort of coming from above, crossing through our y-intercept and our x-intercept, and then slowly tending towards the line x plus 1. All right, and again, if you're uncomfortable with that, the only thing you have to do is pick a number between, in this case, 0 and 1. You would have seen that it was a positive value, so you would know it would be coming from above as well. All right, here's our graph of our rational function. Let's take a look at another. So for the following rational function, the same idea. Before you do anything, you want to fully factor this rational function. Let's go ahead and do that. So fully factoring we get. So now I have my rational function fully factored. We can go ahead and find our x-intercepts. The x-intercepts here are going to be when the top is 0. That'll be at 0, -5, and 3. My y-intercepts happen when I evaluate the function at 0. I have an x-intercept at 0, so right away I have a y-intercept at 0 as well. We have no horizontal asymptote. Regarding vertical asymptotes exist when the bottom is 0, so this is going to be x is 7 or -2. And lastly, to find our slant asymptote, we'll have to go through long division. So going through long division, we get the following. And going through long division here again, we don't have to go through that whole process again. You can see here that my slant asymptote, as we discussed, is always going to be your quotient. So now I know I have a slant asymptote of y equals x plus 7. So now that we have all our information, let's go ahead and graph our rational function. So you'll see here what I've done is I've plotted my 2 vertical asymptotes. I've plotted my slant asymptotes. I've also plotted my points here. We have an x-intercept at 0, another at 3. I should move that one over just a bit. And then we have another one at -5. So again, be mindful of where you're putting these values. You'll notice here that this slant asymptote crosses at -7. This is -2, so I made sure my -5 was between, and then 0 and 3 here. Now I want to go ahead and plot this. So the same idea applies. You want to take a look at your vertical asymptote and see where you're approaching. If I were to be approaching the vertical asymptote from below, I would have to tend up towards my slant asymptote of x plus 7, require me to have an x-intercept here, which I do not have. So therefore, it must be the case that I must be tending from above my slant asymptote of x equals 7, and then it will tend towards my slant asymptote of y equals x plus 7. Okay, so now we want to go ahead and take a look at the other side of the asymptote. So again, I don't know whether I'm coming from below or coming from above here. So I'm going to go ahead and do is I know that this value right here is 3 and this value right here is 7. So I'm going to evaluate the rational function at 4. Evaluating this at 4 here, I end up finding out that the function is negative at that value. So that means I'm coming from below, which means the graph is going to go up. We're going to hit our x-intercept, hit our y-intercept. And now here, it could be the case that it does bounce back up, or does it go back down this way? So quickly, I'm going to go ahead. I know this is at -2. I know this is at 0. I'm going to go ahead and evaluate the function at -1. If I do that, I end up finding that it is also negative. So this will continue on downwards and in the following direction here. So again, same idea with this asymptote. I want to know, am I coming from below or above as I approach this asymptote here? So again, for this asymptote here, I don't know whether I'm coming from below or coming from above. So I'm going to go ahead, and I know that this point right here is -5. I know this is -2. And evaluating this at -3, I end up finding out that the value is positive. So this is coming from above. We cross our slant asymptote, and then it'll tend towards the slant asymptote y equals x plus 7. So now we have our rational function fully graphed here. You've got an example of crossing a slant asymptote, and you have one with 2 vertical asymptotes as well. All right, that concludes today's lesson on graphing rational functions with slant or oblique asymptotes. Thank you.